Okay, similar polygons. Similar polygons. Oh, so we're in the note packet. So you have the supplemental packet and then the note packet. So we're in the note packet right now, guys. Moving straight on. So go ahead and go to 6.1 in the note packet. Can everybody see that okay? Okay. Similar polygons. They are two polygons such that their corresponding angles are congruent. So our angles in these figures are still exactly the same. So remember back to congruent triangles. All angles were exactly the same. All side lengths were exactly the same. In similar polygons, all angles are still going to be exactly the same. The difference is their corresponding sides are in proportion. Meaning, maybe I have a small triangle and I have a larger triangle. They are similar. This one is half the size of this one, meaning that every single side length is half the size, okay? Scale factor, the letter we use in math for scale factor is K, for whatever reason. So the scale factor of a similar polygon's corresponding sides. If K is greater than 0, it is considered an enlargement. If K is in between 0 and 1, essentially, it is considered a reduction. It should actually be 1. If K is greater than 1. Change that 0 to 1. And this is ratio. Theorem 6.1, perimeter and area of a similar polygons. So, if the polygons are similar, then the ratio of their perimeter is equal to the ratio of their corresponding sides. It is their scale factor, or K. However, if two polygons are similar, then the ratio of their areas is equal to the ratio of their corresponding sides squared. Because area is a two-dimensional value. Okay. This right here is the symbol for similar. Who remembers what the similar for congruent is? An equal sign with that tilde above it. So just the tilde means similar. Okay? So they are saying that this figure, ABCD, is similar to this figure, EFGH. What that means is the side length AB over, what side length corresponds with AB? EF is equal to side length BC over side length FG, which is equal to side length DC over good, which is equal to side length AD over EH. It's EH. What that means is that the ratio of their sides should be equal. So for instance, if I did this, that would be 10 over 30. What does 10 over 30 reduce to? 1/3. BC would be 7 over 21. What does 7 over 21 reduce to? 1/3. DC, again, is 10 over 30. We already said that that reduces to 1/3. And then this is 7 over 21 again, which reduces to 1/3. So they are in proportion because they are 1 to 3. That is K, the scale factor. What would I have to multiply this side by to get to that triangle or that figure? What would I have to multiply this by to get over here? Times it by 3. But if I'm going from big to small, what would I have to multiply it by? 1/3. So the scale factor going from the big to the small is 1/3. The scale factor going from small to big is 3. Does that make sense? These will always be reciprocals of one another. Tell me what a reciprocal is. Well, yeah, what were you saying? Yeah. So one way to say opposite, one way to say whatever was the denominator is now the numerator. So remember, reciprocal is taking the fraction and flipping it, right? So 3 as a fraction is 3 over 1. If I flip that, it becomes 1 over 3. What is the perimeter of this guy? And the perimeter of that guy? 34 is correct. What's the area of this guy? 70. Okay. Go down to number 1. Do this for me. List the corresponding angles and the proportional sides. We listed the proportional sides up here. That's what they want whenever they do that. So go down here and list the corresponding angles. Okay, what does angle A match up with? Which one? D. Do you guys see how I wrote this symbol? What's this symbol? Congruent. Why can I write congruent on that guy? Because what do we know about angles of similar figures? They are exactly the same. So we can write that those are congruent. Angle B matches up with angle F, and angle C matches up with angle B. A to B matches up with DF. AC matches up with and then BC matches up with. Okay. Questions? Did I mess up somewhere? Okay. Oh, okay, that's fine. Okay, go back up here. What is the perimeter of this larger rectangle? What did you say? I'm sorry? 102. What do you do to 34 to get to 102? Multiply by 3. And 3 is our what here? Scale factor. So, perimeters, you just multiply by the scale factor, right? What is the area here, though? 630. I guess I should be putting my units on this, huh? How do I get from 70 on this guy to 630? Square root. If I squared 70, that would be 49, add a couple zeros, so that wouldn't be that. You multiply by what? Yep. What was my scale factor again, guys? 3. Remember up here, it says area is multiplied by the scale factor squared. So what's 3 squared? 9. What's 70 times 9? 630. Remember it's squared because it's two-dimensional. It's a length times a width, so it's increasing by 3 times on each side, so a total by 9 times. Okay? So if they don't give you, this is a good question on a test or a quiz or homework assignment. If they give you one of the areas and they ask you to find the other area without any side lengths, you're going to have to multiply by the scale factor squared. Does that make sense? Okay, go ahead and do number 2 completely on your own, start to finish, read it, and then complete that. Okay, guys, on this one, they're asking, are they similar or not? So if they're similar, all angles would be congruent. So I'm just going to look at the first one. Are all my angles matching up? So this is congruent to this, this to this, this to this, and this to this. Yeah, so that's the first thing we need to make sure. Second thing is we need to make sure that they are in proportion. So I'm going to write 4 over 16 and 6 over 24. Those two things should be equal to one another, right? I don't need to write this one and this one because they're exactly the same. So 2 ways to do this. You can reduce the fractions. 4 over 16 reduces to what? 1/4. And then does 6 over 24 also reduce to 1/4? Okay. If they are funky fractions, though, the other thing you could do is turn the fraction into a decimal. Just divide it. So what's 4 divided by 16? Yeah. And when I do 6 divided by 24, I also get 0.225. So you're going to get the same decimal amount. That means that they are congruent to one another, right? So this one is similar. So yes, similar. Okay. This one, this has an angle, 1 arc, 1 arc, 2 arcs, 2 arcs. So first off, are my angles for sure congruent to one another here? No. So angles are not congruent. The other thing is, let's check. 5 over 6 should be equal to 3 over 4. What's 5 divided by 6? Do you guys have a calculator out? And is the 3 the one repeating, right? Okay. And then what's 3 divided by 4? Everybody should know that. So are those two things congruent? No. So these are not similar. Okay? Angles aren't similar, and the side lengths are not in proportion. Okay, go ahead and try number 3 and number 4 on your own. I set these up using this statement, right? So J to L matches up with B to O, so that's how I knew those. To find X, I'm just going to use those two. And all I'm going to do is I'm going to cross multiply. So I do 13.5 times X, which is 13.5X, and 9 times 12, which is what, 108? Is that right? Then to get X by itself, you just divide by 13.5 on both sides, and you get X as how much, guys? 8 centimeters. Yep, that's right. Now, to find Y, you have to use the ratio that has numbers on top and bottom. And I'm going to set it equal to this Y over 7. And then I'm going to cross multiply. So I get 9Y equals, what's 13.5 times 7? Thank you. 94.5. Divide by 9, and I get Y equals how much? 10.5 centimeters. Any questions on that? A little trickier. Do you guys see the 2 triangles? In order to make this work, you actually have to use both triangles and take them out. So I have to do this triangle, the smaller one. Then I also have to take the bigger triangle and take that guy out. And let's label what we know. We know that this is 2x, and we know that this is 9, right? We know that this is 12, but this side over here is the tricky side. What is the length of this side over here? There we go, 3x minus 2. Now I can set up my proportion. 9 over 12 equals 2x over 3x minus 2. Does that proportion make sense? This side over this side equals this side over this side. Go ahead and cross multiply and solve for x. Okay, to solve this one, we did the 9 over the 12 equals 2x over 3x minus 2. Cross multiply, divide, and you get x equals 6. Go ahead and pause me and complete this problem start to finish. And then go ahead and check yourself when you are done to make sure that you got these answers. Your homework will be the Schoology assignment 6.1.